Hello students, today we are going to study problems in ray optics, geometrical optics. A wave or a pulse is reflected normally from the surface of a denser medium back into the rarer medium. The phase change goes by reflection. The answer to the given question is option 3, that is phase change of pi will take place. Whenever any ray or wave gets reflected from denser support, phase change of pi takes place. So option 3 is the correct answer. If an object approaches towards a plane mirror with the velocity v, the image approaches the object with the velocity. This is the object, this is mirror. The object is approaching the plane mirror with velocity v. The velocity of image will also be v in this direction. So the image approaches the object with velocity 2v, okay? Velocity of image with respect to object will be equal to magnitude will be equal to 2v, okay? So out of 4 choice, the correct answer is option 3. Option 3 is the correct answer. An object is placed symmetrically between two plane mirrors inclined at 30 degrees, then the total number of images formed. When angle is 30 degree, number of images formed will be equal to 360 upon 30 minus 1, that is equal to 11. So out of 4 choice, the correct answer is option 3. Two plane mirrors are inclined to one another at an angle of 60 degree. A ray is incident on mirror M1 at an angle I. The reflected ray from mirror M2 is parallel to mirror M1 as shown in the figure, okay? Then angle of incidence. Now, if we look at the geometry, this is angle of incidence I, this is angle of incidence, this is angle of reflection, which is equal to angle of incidence. Normal remains at 90 degree to the mirror, so this angle is 90 minus I. Okay, and this is 90 minus I, so this and this is parallel, so this angle should also be 60 degree. If this angle is 60 degree means what? Dear student, this angle will be 30 degree. This angle should also be 30 degree. If this is 30, then this is 60 degree. So what we can say? 60 degree plus 60 degree plus 90 minus I should be equal to 180 degree, because sum of three angles in a triangle is 180 degree, okay? So 60 plus 60, 120. 120 plus 90 minus 180. So this is how much? 90 minus 90 means 30 degree. So angle of incidence is 30 degree, okay? So out of 4 choice, the correct choice is option 3. Option 3 is the correct choice, okay? In a concave mirror experiment, an object is placed at distance x1 from focus and the image is formed at a distance x2 from focus, the focal length of the mirror. This is Newton's formula where reference point is focus point, okay? Here object is placed at distance x1 and image is getting formed at distance x2. So we will write 1 upon f plus x1 plus 1 upon f plus x2 equal to 1 upon f. After solving this, we will get f equal to under root x1 x2. This is the result of Newton's formula, okay? So focal length answer to the given question is option 2. So dear student, here option 2 is the correct answer, okay? Velocity of light in water, glass and vacuum are the VW, VG and VC. Respect which of the following relation is true? Dear student, velocity in denser medium remains lesser. Refractive index of water is 4 upon 3. The refractive index of glass is 3 upon 2 and vacuum is 1. Okay, so in vacuum velocity is highest, then water. Vc is higher than Vw and Vw is higher than Vg. Okay, Vc greater than Vw and Vw greater than Vg. This is correct answer. Option 2 is the correct answer. Because velocity in a given medium is given as c upon mu medium. Okay, so velocity in vacuum is greater than velocity in water is greater than velocity in glass. So out of 4 choice, the correct choice is option 2. Light of frequency 5 into 10 power 14 hertz is traveling in a medium of refractive index 1.5. What is the wavelength? Speed of light in vacuum 3 into 10 power 8 meter per second. Dear student, frequency is given, traveling in a medium, so velocity can be found. What is lambda medium? Lambda medium equal to lambda air upon mu medium. What is lambda air? C upon mu, and this is mu medium, this is 1.5. So if we solve this equation 1.5, this will get cancelled by 2. So this is 2 upon 5 into 10 power minus 6. Okay. So this is how much? 0.4 into 10 power minus 6 meter. 4 into 10 power minus 7 meter means 4000 angstrom. So out of 4 choice, the correct choice is option 4 is the correct answer. Okay. The refractive index of water, glass and diamond. Water, glass and diamond are 1.33, 1.55, 1.5 and 2.4 respectively. The relative index of refraction of diamond relative to water and glass relative to diamond respectively. See here, diamond relative to water equal to refractive index of diamond divided by refractive index of water. So this will be 3 upon 2 upon 4 upon 3 means how much? This is 9 upon 8. 9 upon 8 means how much? Refractive index of, sorry. Refractive index of diamond is 2.4 and refractive index of water is 4 upon 3. So this is 2.4 into 3 upon 4. This is 0.6. So this is 1.8. Okay. And refractive index of glass relative to diamond. Refractive diamond relative to water and of glass relative to diamond. Glass means how much? Diamond means 2.4. So this is 5 upon 8. 8 upon. So answer to the given question is 1 of. This is how much? 0.6, 2, 5. So out of 4 choice, the correct answer is option 1. Option 1 is the correct answer. The refractive index of material varies with wavelength according to Cauchy's relation. This is used in prism. So out of 4 choice, correct choice is option 2. A ray falls on a prism ABC, AB equal to BC and travels as shown in figure. The minimum refractive index of the prism material should be, because here TIR is taking place. And since AB equal to BC means these two angles are 45 degree, 45 degree. Okay. Now, if the things are like this is the light ray. This angle is 90 degree. This angle is 45 degree. This angle is also 45 degree. This is 90, so this is 45 degree. So this is also 45 degree. For TIR to take place, this 45 degree should be greater than equal to sin theta c. This is 1 upon root 2 greater than equal to 1 upon mu. So root 2 mu should be greater than equal to root 2. So minimum is root 2. Okay. Out of 4 choice, the correct choice is option 2. Option 2 is the correct choice. Okay. The refractive angle of prism is 40 degree. A ray of light is incident at an angle 38 degree and passes in the position of minimum deviation. The angle of minimum deviation means the situation is like this. In case of minimum deviation, this light ray remains parallel to the base. Okay. And this is the diagram. The situation of minimum deviation comes when I remains equal to E. This is I and this is E. Angle of emergence. Okay. And what is I? I is equal to A plus delta M upon 2. So I equal to A plus delta minimum upon 2. After solving this equation, we will get this is 2 at 6, 76 minus 40 equal to delta minimum. So this will get 6 minus 0, 6, 7 minus 4, 3, 36 degree. So minimum deviation is 36 degree. So out of 4 choice, the correct choice is option 3. Option 3 is the correct answer. Okay. For a prism, graph between angle of deviation and angle of incidence will be. The graph between angle of deviation and angle of incidence remains like this. This is asymmetrical, this is not parabolic, and this is called grazing emergence, where angle of deviation remains maximum, and this is called grazing incidence, where also angle of deviation remains maximum, and this is minimum deviation situation. Okay. And this angle is limiting angle of incidence, which is what? Sine inverse under root mu square minus 1 sine A. A is prism angle minus cos A. Okay. So if angle of incidence remains angle of limiting angle, then TIR takes place. Okay. So angle of deviation becomes meaningless. Okay. This is the situation. Okay. So out of 4 choice, the correct choice is option 1. So we will take option 1 as correct answer. Okay. Though this graph will not come in this direction. Okay. This comes here. The refractive indices for red, violet and yellow light are 1.42, 1.62 and 1.5. The dispersive power of the medium will be. Dispersive power is written as mu v minus mu r upon mu y minus 1. So we can say what is mu v? Violet 1.62. What is mu r? that is 1.42. What is mu I? 1.5 minus 1. So 220, 642.2 upon 0.5. So this is 2 upon 5 means 0.4. So out of 4 choice, the correct choice is option 1. The radial curvatures of a double convex lens are 15 centimeter and 30 centimeter, and refractive index is 1.5. Then its focal length is. Dear student, this is the case where radius of curvature of this part is 15 centimeter, of this part is 30 centimeter, and refractive index here is 1.5. So focal length can be written as mu minus 1 upon R1. R1 is positive, minus 1 upon R2. R2 is negative. So here this is 0.5, this is 30, this is 2 plus 1. So 1 upon 2 into 1 upon 10. This is 1 upon 20. Okay. So answer to the given question is plus 20. So F will come plus 20 centimeter. So out of 4 choice, the correct choice is option 3. Option 3 is the correct answer. Okay. Two convex lenses of equal focal length F are placed in contact. The focal length of the combination is important word, that it is placed in contact. Okay. When they are placed in contact, 1 upon F directly 1 upon F1 plus 1 upon F2 means 2 upon F. So dear student, F equal to F by 2. This is equivalent focal length. Out of 4 choice, the correct choice is option 1. Two thin lenses of focal lengths 20 centimeter and 25 centimeter are placed in contact. The effective power. Power is written as 100 upon F when F remains in centimeter, unit is diopter. Okay. And when lenses remains in contact, power remains equal to P1 plus P2, and power for convex lens we take to be positive. Okay. So 100 upon 20 plus 100 upon 25. So this is 5 plus 4. This is 9D. Okay. So out of 4 choice, the correct choice is option 4. Option 4 is the correct answer. Okay. If I1 and I2 be the sizes of the images respectively for the two position of lens in displacement method, then the size of object is given by. This is the case of displacement method. This is displaced position. This method remains valid when focal length remains less than d by 4. What is d? D is the distance between object and screen. Is equal to under root I1 I2. So out of 4 choice, the correct choice is option 2. Option 2 is the correct answer in this case. Okay. In a simple microscope, if the final image is located at infinity, then magnifying power. In case of simple microscope, the magnifying power is given as d upon f when image is located at infinity. Okay. So here d equal to 25 centimeter. Okay. So option answer to the given question is option 1. If FO and FE are the focal length and objective and eyepiece respectively, then the magnifying power of the telescope will be. In case of telescope, this is objective lens and this is eyepiece. Okay. And the magnifying power remains equal to FO into FE, and the tube length remains FO plus FE. So out of 4 choice, the correct choice is option 2. Two convex lenses of focal length 0.3 meter and 0.05 meter are used to make a telescope. The distance kept between them is equal to. In case of astronomical telescope, the tube length remains equal to FO plus FE. So this is 0.3 plus 0.05. This is 0.35 meter. Okay. So out of 4 choice, the correct answer is option 1. Option 1 is the correct answer.